Assalamualaikum, my name is Intan Syuhada. My metric number is 13DKA223F1033. I would like to present about the fluid mechanics, which is hydrodynamics. For the hydrodynamics, is a branch of physics that studies the behavior and motion of fluids, particularly liquid, as they flow and interact with force and boundaries. This field encompasses the principle governing how liquid respond to change in pressure, velocity, and external force, offering insight into both natural and engineered systems. From predicting ocean currents and weather patterns to designing efficient pipelines, turbines, and ship, hydrodynamics plays a crucial role in multiple scientific and engineering disciplines. Next, I would like to explain about type of fluids. There having a 10 of type of fluid. First thing first, steady flow. A flow is defined steady when its characteristics like velocity, density, and pressure at a point do not change with time. For example, a constant discharge through a pipe. Secondly, for the unsteady flow. A flow is defined when the fluid characteristic velocity, pressure at a point change with respect to time. For the example, a variable discharge through a pipe. Secondly, for the uniform flow is a type of fluid in which is the velocity of the flow at any given time does not change with space. For example, constant discharge through a constant diameter pipe. Next, for the non-uniform flow. A uniform flow is a type flow in which the velocity of the flow at any given time change with respect to a space. For example, constant discharge through a variable diameter pipe. Next, for the laminar flow, turbulence, and transition. When fluid particles move along well-defined paths and the paths are parallel and straight, that is laminar. Laminar flow generally happens when dealing with small pipes and low flow velocity. If particles with higher velocity move in a zigzag manner and eddies are formed, the flow is called turbulent. Turbulent flow happens in general at high flow rates and with larger pipes. Turbulent flow are unsteady flow. Lastly, transitional flow occurs in a critical zone where the average velocity change the flow from laminar to turbulent. Okay, that's all for me.
Okay, Assalamualaikum. My name is Siti Aisyah binti Ismail. My matrix number is 13DKA23F1027. And today I'm going to talk about types of fluid flow. Okay. There are 5 types of fluid flow, which is the first one is compressible flow. Second one is incompressible flow. The third one is rotational flow. The fourth one is irrotational flow, and the last one is 1, 2, and 3 dimensional flow. Okay, compressible flow is a flow in which the volume of a fluid and its density change during the flow. It is called a compressible flow. All the gases are considered to have compressible flow. Okay, incompressible flow is a flow in which the volume of a fluid and its density does not change during the flow. It is called incompressible flow. All the liquids are considered to have incompressible flow. Okay. The next one is rotational flow. Rotational flow is a type of flow in which the fluid particles rotate about their own axis while flowing along the streamline, and is called a rotational flow. Okay, in irrotational flow is the fluid particle while flowing along the streamline do not rotate about their own axis. Okay, the last one is 1, 2, and 3 dimensional flow. It's a flow in which the streamlines of its moving particle are represented by straight line. A flow whose streamline of its moving particle are represented by a curve is called two-dimensional flow. Okay. A flow whose streamline are represented in space along the three-dimensional mutually perpendicular is called a three-dimensional flow. Okay, next I'm going to talk about Reynolds number. The Reynolds number is a dimensionless quantity in fluid mechanics that helps predict the flow pattern of a fluid, such as whether it will be laminar smooth or turbulent chaotic, named after Austin Reynolds. This is a fundamental concept in hydrodynamics, serving as critical indicator of fluid behavior under varying conditions. Okay, that's all from me. Thank you.
Hi and Assalamualaikum. My name is Nurul Shazwana binti Rosli, metric number 13 DKA 23F 1042. Okay. I will continue the next slide. The flow. Okay, we have three type flow. First, laminar flow, transitional flow, and turbulent flow. Okay, first we start with laminar flow. Okay, kalau laminar flow ni, dia kurang daripada 2000. Dia low velocity. Dye does not mix with water. Jadi, dia punya aliran tu slow je. Okay, yang kedua, transitional flow. Dia lebih pada 2000 tapi kurang daripada 4000. Dia juga medium velocity and filament oscillators and mixes slightly. Okay, yang ketiga, turbulent flow. Okay, kalau yang ni paling laju, aliran dia paling laju, dia lebih pada 4000. Jadi 4000 ke atas. Dia juga high velocity and dye mix rapidly and completely.
Hai semua, saya TVS Sri Sivakumar nak terang tentang presentation kita buat untuk fluid mechanics, topik hydrodynamics. Pertama kali, kita pasang pipe transparent ke pili dan buka air dalam keadaan perlahan. Lepas itu, kita menyuntikkan picagari yang diisi dengan pewarna makanan. Selepas itu, kita melajukan pili dan sekali lagi menyuntikkan picagari ke dalam pipe itu. Akhir sekali, kita buka pili ke laju dan menyuntikkan picagari ke dalam pipe itu. Kesimpulannya, kita buat eksperimen ini untuk menunjukkan jenis fluid flow, iaitu laminar flow, yang mana flow yang perlahan dan Reynolds number dia kurang daripada 2000. Seterusnya, transitional flow, yang mana flow yang sederhana dan Reynolds number dia 2000 hingga 4000. Akhir sekali, turbulent flow, flow yang paling laju dan Reynolds number dia 4000 ke atas.
Okay, seterusnya kita akan teruskan dengan exercise. Okay, soalannya gini. An oil of specific gravity of 0.95 is following through a pipeline of 200 mm diameter at the rate of the 50 liter over second. Find the type of flow if dynamic viscosity for the soil is 0.1 ns per meter kuasa 2. Okay, jadi yang pertama, kita tulis dulu key point soalan ia. Macam ia bagi dah, GS sama dengan 0.95, diameter sama dengan 200 mm, Q sama dengan 50 liter per second, dan dynamic viscosity 0.1. Lepas kita tulis ia punya data semua tu, kita tukar unit pula. Macam diameter tukar kepada meter, 50 liter per second tu kita kena tukar unit je. Jadi meter kuasa 3 per second. Macam yang dalam gambar tu, kita tukar yang di kanan tu. Jadi dapat 50 darab 10 tolak 3 meter kuasa 3 per second. Lepas pada dapat tu semua, kita tulis formula dia. Formula dia sama dengan RE sama dengan rho VD per dynamic viscosity. Lepas tu, kita kena cari pula rho tu apa. GS kan telah dibagi. Jadi kita masukkan GS sama dengan rho per rho W. Jadi 0.95 sama dengan rho per 1000. Tu ada salah sikit tulis. Patutnya rho W tu 1000 bukan 100. Jadi rho kita akan dapat 950 kg over meter kuasa 3. Okay, lepas tu dapat tu kita kena cari pula area. Sebab kita kan nak cari velocity. Jadi kita cari dulu area. Area sama dengan pi d kuasa 2 per 4. Jadi D bagi dah. Jadi pi D tu kita tukar jadi 0.2 kuasa 2 per part. Jadi area kita akan dapat 0.031 meter kuasa 2. Okey, seterusnya untuk kita cari V pula, kita ambil formula ni, Q sama dengan AV. Jadi Q ya 50 darab 10 kuasa tolak 3 sama dengan A area ya 0.031 darab dengan V. Jadi kita bahagi dapat V sama dengan 1.613 amperes. Jadi dapat semua tu kita masuk dalam formula ya je. Jadi rho ya sama dengan 950 darab dengan velocity ya 1.613, diameter ya darab dengan 0.2 per dengan dynamic viscosity ya 0.1. Jadi dapat jawapan 3064.7. Jadi ia punya type of flow is transition flow, sebab transition flow kan ia lebih pada 2000 tapi kurang pada 4000. Jadi ia tengah-tengah. So, the conclusion is, in conclusion, hydrodynamics is a vital field of study within fluid mechanics that explores how liquids behave under various forces and in diverse environments. By understanding principles like the conservation of mass, energy, and momentum, hydrodynamics enables scientists and engineers to predict fluid behaviors accurately, informing the design and optimizing of countless systems, from pipelines and marine vessels to atmospheric models.
Thank you.